So, hello everyone. My name is Apoorv, and as you can see, I will be talking about how to build Starknet Appchains and what exactly is Madara. So, before we get into that, let's quickly talk about me. So, my name is Apoorv, and as he just mentioned, I'm a core contributor and maintainer at Madara. And I'm also the founder of Carnot.xyz. So we just announced Carnot this morning, actually, and it's a roll-up as a service that helps you deploy app chains using the Starknet technology. So that's about me, and let's get into the talk. The first thing is obviously the basics of app chains. I won't be going like very deep into this, mainly because I think most of the people over here probably already have a mindset that they want to build an app chain, and I think they're trying to figure out which one is the best. And I also think the people before me probably did a very good job about explaining why app chains are important. But I will still take like a minute or two. So basically, initially we had Ethereum, which proved, like general purpose compute makes sense, decentralized compute makes sense. And then we had the bull market, so Ethereum blew up, and we had extremely high fees, very low slow transactions, and people said we'll make layer 2s. So then we had Starknet, Arbitrum, Optimism, and so many other layer 2s that exist as of today. But they were merely general purpose chains again, right? So you could just like deploy smart contracts in the language that they support. You restricted a lot of the general purpose overhead over there. Like if they take a conscious call that they're only going to allow maximum gas of 1 million, then you have to obey that. If they choose that they'll only use this specific VM, you have to choose that. And eventually, that's why we now start seeing a lot of people building app chains, because you want more sovereignty, whether it's in terms of your assets or you want more control of your tech stack. Like, you want to be able to control what VM you're using, what prover you're using. And at the end of the day, it's like if I just say, like all the future is going to be on one general purpose rollup, it's like saying we have made like Node.js version 18, and like this is the final version, everyone will deploy on this. And it becomes very, very difficult to keep it like up to date then. For example, like pushing dank sharding on Ethereum today or adding single slot finality on Ethereum today is going to take for like years. Whereas like if you want on your app chain today, you either have to wait for Ethereum or you can just like push out and make your own chain. So that's the basic reason behind app chains. It's not like a new concept. And Starknet, honestly, is like one of the oldest players in this ecosystem. So just a disclaimer, I'm officially not from Starkware, but I've been involved in the Starknet ecosystem for almost a year now, and I'm also building the roll-up as a service around the ecosystem. So yeah, Starknet has actually been one of the oldest players over here. I'm not sure if the first diagram is sort of visible clearly, but if I rank all the chains today based on their volume in descending order, the first and the fifth one are based on the Starkware technology. And the first one, that's DYDX, I'm sure many of you guys have heard of it. And like the volume of DYDX today is, I think, more than the combined of all other four. I took this screenshot a few days ago. I'm sure it's pretty much the same case. There's Immutable, there is SoRare. All these guys are based on the Starknet stack. And today, combined, I think Starkware has done more than $1 trillion in trading. And it has probably minted more than 1 million NFTs. It's like where I'm going with this is that the Starkware technology is really battle-tested, and Starkware has been doing this for a lot of time. And before this, before we actually came up with Madara and Carnot, if you wanted to build a roll-up with the StarkX technology, you actually had to, talk to Starkware, and you had to like come up with a partnership sort of thing where you can like agree, like, okay, this is the kind like provable language we want to use. This is the code that we want to prove. But eventually, Starkware realized that, like this is going to, like this is not the way we want to approach it, because it's clearly working. But we want everyone to just be able to just use our stack out of the box. You don't need to come to us and say like, hey, you know what, like let's partner, I want to build my app chain, none of that. So that's why Starkware decided to make Starknet as a general purpose chain. So we have Starknet today, which is a general purpose chain, which obviously has its own use cases. But if you want to use the Starknet technology but have your own app chain for the same reasons I mentioned before, we now have Madara. So for the anime fans over here, like there are a lot of anime freaks at the Starknet ecosystem. So a lot of our projects are named after them. But Madara is basically a framework for building ZK rollups. And the idea is that if you are building a ZK rollup, there are a lot of paths which are common across every ZK rollup. For example, you have to settle your data somewhere, you have to prove your transactions, you have to decide which virtual machine you are using. So there's a lot of things that are common to like all the ZK rollups, and we want to abstract that away from the user. We don't want our developers or our like users to be worried about repeating the same thing over and over again, which is why we made Madara, which is like a general purpose framework for you to build a ZK rollup. And the second point is linked to the first one. So because it abstracts all the redundant information from your side, you can focus just on your business logic. So you can like, one of the reasons of making Appchains is that you want your product to be really differentiated, and you probably want to offer like the world-class experience. So that's what you can do. You can just focus on that instead of like worrying about, okay, how is the consensus going to happen, how is the P2P going to happen, and so on. And with that being said, the third point is still very important, and that is that we are modular from day one. And what that essentially means is that even though we are abstracting away a lot of the important things so that you can focus on your logic, we let you modify it whenever you want. So all our technology is very modular, and let's suppose you want to swap out the virtual machine for your own virtual machine, you want to change the prover and use your own more advanced prover, you are free to do that. So yeah, you can technically just modify any part of it you like. And achieving that modularity is actually not easy. It's very difficult. And there are a lot of stacks that exist as of today. I'm not going to say which one is better, which one is not good. There are obviously trade-offs. But what I'm going to say is that not every stack is going to be very modular, because this is a very difficult problem to solve. Because when you're building these chains for the first time, it's very easy to hard code something somewhere, because of which now later if you try to change it, you probably have to make changes in like 10 other places, and everything is going to break. So I just want to stress that that's a really, really important point that we offer as of today. And I'll also show you how, because like the advantages of that point we're seeing right now. So yeah, how do we achieve modularity? Thanks to Substrate. So if any of you guys are familiar with the Polkadot ecosystem in general, you probably have heard of Substrate. So Gavin Wood, who was like the founders and CTO of Ethereum, he left Ethereum, I think around 2015, 2016. I don't know the date, but he realized that we're doing a lot of repetitive work when making blockchains. So he decided that when we are building Polkadot, we won't just build Polkadot, but we'll actually build a framework this time. So all the work that was involved in building Bitcoin and Ethereum, you don't have to repeat that every time now. We'll build a framework so that anyone who wants to build a blockchain from now on can use this framework directly. And that's basically called Substrate. And one of the best parts about Substrate is that it's completely chain agnostic. So there is no Polkadot which is hard-coded into the design of Substrate specifically. So you can build anything. You want to build proof-of-work chains, proof-of-stake chains, everything is possible. And fun fact, even the Avail team, who have organized this amazing event, they are using the Substrate stack as well. And like many, many people in the Ethereum ecosystem are now starting to realize that it doesn't make sense to solve for the entire blockchain framework all over again, because there are people like Substrate who are doing it for years, and they're battle tested, because I think there's a good number of chains who are using Substrate today, and they're probably securing, I think, more than $5 or $6 billion. Polkadot being one of them, obviously. So it's battle tested. There's tons of dev tooling around it. So if you're building an app chain using Substrate, you get access to a lot of dev tools for debugging or for just like analyzing your transactions. And obviously, there's a very strong developer community. Like Polkadot today has the second largest developer community only after Ethereum. So these are all the advantages if you're going to be using Substrate out of the box. And I still didn't actually answer how is it modular, right? This is the advantage of Substrate. But how Substrate actually becomes modular is using this thing called pallets. So the way you can actually think about pallets is they're like libraries. So you know how you have, if you're building something on, let's say, Node.js or Spring Boot, you have these libraries that you can use out of the box. For example, I can just install Express.js and build my backend. I can use Spring Boot and build my backend. I don't need to worry about things like how's the TCP connection happening, what happens if packets get lost. All that thing is like abstracted away from me. In Substrate, this idea of libraries is called pallets. So basically, pallets define specific functions of your blockchain. They could be what finality gadget are you using, what virtual machine you are using, how's the block production working, and a lot of different things. And like, since this Substrate stack has been here for like 4 or 5 years, you can already find a lot of pallets today out of the box, which you can just plug into your chain. And when you decide what pallets you want to use, you can just like combine them here and there, and you can build your runtime, which technically defines your blockchain. So that's how that's how Substrate achieves modularity. And as you might have guessed, what we have gone ahead and done with Madara is that we've created our own palette called Pallet Starknet. And Pallet Starknet basically gives you a lot of features out of the box. And I'll just quickly go through what happens when you're using Madara to build your app chain. Like, what are the things that you can get out of the box? So the first thing is the Cairo virtual machine. And those of you who are not very familiar with Cairo, it's basically a provable language. It lets you write smart contracts which are provable. Starknet didn't really go the route of building a CKVM because we wanted to build something that was provable from day one, and it was made for proving. So since Cairo is being made for proving the execution, it's much more efficient than other virtual machines that exist today. So yeah, basically, if you integrate the Pallet Starknet into your app chain, you will get the ability to write Cairo smart contracts on your app chain. The second is the Starknet RPC. So basically, you get the RPC, all Starknet RPCs compatible with your app chain from day one, which means all the tooling like wallets, Starknet.js, RS, and all those libraries that just rely on an RPC, they're going to work out of the box. You don't have to do any changes, and they'll just work with your app chain. You get proving. So as of today, we have the Sharp Prover by Starkware, which is, it's actually, the prover is called Stone, and Sharp is a service that Starkware provides that can be used for proving any execution. And we integrate that with Madara, so basically, you don't need to worry about how the Cairo contracts or how the execution is going to be proved. We'll handle that for you, but as I said, it's going to be modular. If you want to take that out and maybe use your own prover, or you want to use a prover of some other company, you're like free to do that. And finally, is the DA and settlement part. And we are very, very, you can say, settlement or DA agnostic. We don't force you to use a specific settlement layer. You can use anything you like, Celestia, Avail, Ethereum. And we're actually like very closely working with Avail as well. And we'll probably be launching a small testnet with Madara. So there's a good chance that we'll be using Avail as a DA layer for that. So it might be a good thing if you want to experiment. But yeah, we're very agnostic. You can choose whatever you want over there. And yeah, as I said, like I really want to stress on this point that it is really modular. So, and just like I just want to show like what are the things that have been made possible because of our stack being modular. So these are some of the companies who are not developing the Madara stack itself, but they just they saw Madara, they found it useful, and they decided they wanted to contribute over here. And some of them, for example, Web3MQ has a very close implementation of hot stuff for Madara. So if you want your app chain to have hot stuff for it, you can just use it out of the box. The Radius is a shared sequencing company that built an encrypted mempool. So if you want your chain to have encrypted transactions like no MEV, that's your probably go-to choice for today. We have Deoxys, who's building a full node with the Madara stack. And finally, obviously, there's a lot of Polkadot tooling that just exists out of the box because we are using Substrate. So there's a lot of pallets that you can just use and integrate with Polkadot if you want as of today. So yeah, it is really modular, and it's open source. So Madara is 100% open source. We have more than 70 contributors as of today, I think, spread over 15 plus countries. So if you're someone who wants to use the Madara stack you want to contribute and add more things and more features to the Madara stack, feel free to contribute. And also, if you're someone who just wants to build an app chain, you don't need to contribute to Madara itself, but you can just use the app chain template we have to build your own chain. And I'll actually be showing a very quick demo soon on how you can do that. And finally, yeah, because I think a lot of the talks today are like basically different ecosystems presenting their SDKs. So while I believe that each SDK has their pro and con, and it's depending on your app chain what you want to use, you can decide which SDK you want to go ahead with. I want to present why I think Madara might be a good choice for you so that you can take your decision. The first thing is obviously advantages of ZK. So this is if you are analyzing, do you want to use ZK or optimistic rollups, then I would say you can use ZK, number one, if you want cheaper data availability. So with optimistic rollups, you sort of have to post all your transactions on the DA layer. For example, if like there are two people who have been exchanging millions of transactions with each other, uh, but at the end of the day, it's just these two who are like updating their balances. Like A sends some money to B sends some money back to A, and so on. In optimistic rollups, you have to post all those transactions on the DL layer to be able to create fraud proofs. Whereas in ZK rollups, you have the ability to just post the state diffs. Like you just have to post that the final state is A has this much balance and B has this much balance. So you don't need to post all the transactions. Obviously, there are cases where actually posting transactions might be cheaper for you, but if you're building something like a DEX or a perpetual exchange or something of those sorts where there's a lot of trading and exchange of assets, then you can probably have cheaper data availability if you're having if you're using ZK. And second is just faster finality. So if you want your chain to be interoperable with other chains and other ecosystems, you just have faster finality if you're using a ZK system. And otherwise, if you're using something in the optimistic case, you might have to rely on someone or a third party to give you that faster commitment when interoperating. The second, once again, is modularity. Won't go deep into it, like I've already talked a lot about, I guess. But yeah, it's just very, very modular. So you find a lot of libraries and a lot of things you can just use out of the box. And finally is the app chain experience. So I think Starknet and Starkware in general are some of the most experienced players in building app chains. And I think like the products like DYDX, Apex, Immutable, all of these speak for themselves. So it's just that a lot of the tech that Starkware is using is battle tested, and it has shown that it works for app chains, and now we're just making it open source and making it available for everyone to build your own app chain. So yeah, let's build something. I have my laptop connected over there. What I'll quickly try to do is, through this demo, I'll try to show you like how an app chain template is structured. So you can look at that, and you can get an understanding how you can build your own app chain. And then we'll try to like go through a hypothetical use case of building an app chain template. So like, I'll give you an example where an app chain would make sense, and we'll try to replicate that over here. Yeah. I think it's
So this is like an extended screen. You have to like drag and
okay. Can I mirror it?
you can.
Okay. Um, cool. Is this readable? Do you want me to increase the font size or? Cool. Awesome. So this is a Madara app chain template. So the first things first, if you're going to be using Madara to build your app chain, I wouldn't recommend to fork the actual Madara repository. Like I said, we have made a pallets Starknet for you, where you can just import into your app chain and get a lot of the functionality out of the box. So I would say that there is a Madara app chain template that we have. So you could go to, if I just, it's called Keep Starknet States, the organization, and we have a Madara app chain template. I would suggest that you just clone this, and you can start building your app chain from there. Although with that being said, I would also say that there are some very specific advantages you can have by probably forking Madara. Like if you want to really, really maybe add a new syscall, or I think you call it precompiles maybe in Ethereum, you can do something like that. But for a lot of the use cases, and the use case that we'll be demoing today, you don't need to fork Madara. You can just use it as a plugin library. So those of you familiar with Rust, you would probably know that you have a crates folder which has all your different packages. So I'll quickly run through the different sort of packages we have available right now. You have the node crate, the node crate is basically, it has the main.rs file. So this is where your node technically starts. But you mostly won't be doing a lot of changes over here. Like it's just a lot of boilerplate code to get your node running. So that's what exists in the main RS. We can just quickly go through the other files. There's a command file. So like when you finally build your binary for your app chain template, there are different commands you can use, like to start the chain, to set up the chain, benchmark it, purge, and so on. So you don't really, mostly you won't need to play with this because by default, Substrate templates offer a lot of the functionality. But if you want to add a new command, then this is the file that you're looking for. There are a few other files over there, but we won't go into the depth. Mostly you won't be making any changes to the node crate. Then we have the runtime. So the runtime crate is, this is the important part. And I think like for a lot of your app chain use case, you actually might be playing with the runtime crate to configure a few things. And let me show you what you can configure. So the first thing is just block time. So if you go to the config file in the runtime, you can see we have a block time over here. It's currently at 6,000 milliseconds, which means there's a new block every 6 seconds. But if you're building your own app chain, you probably want more sophisticated block times, like 500 milliseconds, and you just want faster execution. With that being said, I'm not going to say like just reducing the block time is like going to work magically. If you're centralized, probably yes, but you have to take into consideration how beefy do you want your nodes to be if you want to decentralize, how many transactions you want to allow per block, because if you're reducing the block time, it has some other concerns. But mostly, if you're just building like a centralized app chain, you can probably reduce the block time and have faster blocks and commitments. So yeah, that's the config for block time, and let's look at the config for pallets. So like I said, we have the Starknet pallet. So let's see what are some of the interesting things that we can possibly configure with that. Uh, for example, we have the maximum number of steps. So in Cairo, we call it steps, similar to Ethereum gas. Like we also have gas in Starknet, but right now, if you want to think of steps, the analogous is gas. So what's the maximum number of steps a specific transaction can have? You can play around with that value. So a very interesting use case someone had at Starknet was they built snarks on top of Cairo, but they needed like more than the maximum limit allowed. Eventually, Starknet increased their max limit on chain, but I'm just trying to show you that if you have something that's really complicated and it just doesn't make sense to make it on a general purpose rollup, you can use your app chain and just increase the limit. You can do the chain ID, the recursion depth. Another interesting thing is like the transaction fees. So let's say like you figure out a way to just find a different way to monetize validators and like a different way to prevent spam. You can just disable transaction fees as a whole by just changing the disable transaction fee value to true. If you're familiar with Rust, we're using a feature flag here so that you don't even need to change anything in the code. You just build with the feature disable transaction fees and it works. So that's the some of the configurations that you can do with the Starknet palette. There's also a palette crate. There's nothing complicated over here in the template. The purpose of the palette crate in the template is just to show that if there is some other interesting palette you want to integrate, then it's possible. Cool. So that's a basic structure of the AppChain template. Let me now create a hypothetical scenario of when an AppChain would make sense. And let's see how we can play around with that over here. So the hypothetical scenario is, let's assume I'm Circle, and I have the USDC coin. So everyone who's using USDC on Ethereum or any other chain is in some way already trusting Circle, right? So I come up and I say that I want to build my own centralized chain, which is only meant for payments. So I'll build this app chain, and the purpose of this app chain is just going to be to pay like one user to, like you can make payments between users. And let's see how like I can start with a basic stack and then like improve them slowly, so have a very efficient chain just for this purpose. So the first thing I'll do is I'll have only smart contract wallets on my chain. I don't want users to be like using EOA accounts because they have private keys. They can be hacked. So I'm only going to be allowing smart contract wallets in my chain. By the way, Starknet has native account abstraction as well. And I think it's one of the few chains that has native account abstraction. But I'm going to show you how we can go even ahead of that. So if you just want native account abstraction, there's already Starknet, but you can go one level ahead of that. So this is how my account looks like in Cairo. And there's a validate function over here, which validates if the transaction is correct. And since this is my centralized app chain, I can do whatever I want over here. I can change the VM and other things. So I'm going to change this validate function, and I'm going to add an OTP section. So like, I don't want my users to remember a private key. Since you're anyways trusting Circle with your USDC, you might as well trust me with an OTP. So like, whenever you want to make a payment, you have to enter a one-time password that I will generate and share with you. How do I check that password in my smart contract? I add a syscall. So in your smart contract, you add this new function, which will validate if an OTP is correct or not. For the purpose of this demo, I've just hard-coded it to 1, 2, 3, 4, 5, 6 over here. I hope it's visible. Yeah, I've just hard-coded this to 1, 2, 3, 4, 5, 6, just for the purpose of this demo. But if you want, yeah, you can just add a new function to your virtual machine altogether. So yeah, this is how accounts will look like on my chain. I've already built the chain, and I have a dummy front end just to play around with it. Yeah, so this is the dummy front end I have with me right now. Let me quickly get the, actually before that, let me show you how you would want to start and set up your chain. So I have the binary with me, which is AppChain node. And if you want to set up your chain, you have to run the setup command. So over here, you have the profile that you want to use for your chain. I'm going to call it dev profile because it could technically be anything. You could do dev 1, 2, 3, dev 4, 5, 6, or anything you want. But I'll keep it to dev because it helps me with another command later on. And the from local path specifies what is the config, like where is the genesis state of your chain stored. So if I go back to the app chain template, sorry, okay. Yeah, if I go back to the AppChain template, there's a config folder, and this specifies what the genesis state of your chain looks like. So like I've already kept a pre-deployed account over there so that we can play with it today. So yeah, I'm just going to quickly set up my chain, and now I'm going to start my chain. So this is the command that I'll use. I'm specifying the dev flag. So the dev flag is basically like it's like a boilerplate sort of flag, not boilerplate, but it's a flag that substitutes with a lot of other flags by default. So like it gives you unsafe RPC calls for development. It allows you to author blocks with just one validator, and a lot of other things that just basically make development easier. So that's why I used the dev profile earlier. And finally, I'll just say allow disable cores basically. So yeah, my app chain is up and running, as you can see over here. What I'm going to do right now is I'll come back to my front end. Let's check how much balance I have in my pre-deployed account. So it's around 1 million ETH. And now what I'm going to do is I'm going to transfer some funds to this account called 123. I'll transfer 1 ETH. So I'll transfer, get balance, again, one more time. Yeah, there we go. So two things to notice here. One thing, it took a lot of time, which doesn't make sense. I'm building my own app chain. I don't want my users to be waiting for so long to do payments. And the second thing is you'll notice that I lost more than 1 ETH, right? I lost some amount in the transaction fees. So two things we want to do over here is disable transaction fees for a chain and increase the block time. So let me do that real quickly. Sorry. Yeah, so for reducing the block time, as I said, I'll just reduce it to like 500 milliseconds. So we have faster blocks now, and we are centralized. So it's all cool. There are not a lot of considerations we have to take in over there. The second thing for disabling transaction fees, like I mentioned before, we just have to build with the disable transaction fee flag, and it should work. Another thing I want to do is, actually, you can see the native token of this chain is called ETH. That doesn't make sense for us. Our native token should be USDC. So let me quickly fix that as well. I'll go to my Genesis state. Your Genesis state defines what are the pre-deployed contracts, what are the storage slots within these contracts. So I'll just go over there, and I'll quickly just find out. Yeah, this is the part that says ETH. So I have a quick converter over here. So you can see that the hex representation of that number is ETH. And I'm going to replace that with the hex representation of USDC. Sorry. Yeah. There we go. So that's the hex representation of USDC. And if I come back to my chain now, I'll have to make one more release. So this could take like, sorry, cargo build. Yeah, so I'm going to be disabling the transaction fees and creating a new build. This could take like a minute or so. So till that happens, I would actually want to let you guys know that we have a Madara-specific event, which is happening on the 14th of November. So if any one of you guys want to attend that event, there will be a lot of people from the Madara core team, from Starknet. If you just want to talk about how Madara works or how you can build your app chain, feel free to come over here. And yeah, and if you guys want to build app chains with Madara as well, like I said, we just announced Carnot today morning. You can go to our website, carnot.xyz, or you can follow us on Twitter as well, and we should definitely chat if you guys want to build your app chain with Madara. Let me check. OK, it's still building. I think we're almost done over there. So three things we want to check now is that, OK, it's done. Let me quickly set up the chain again, because I've updated the Genesis config. And let me quickly start the chain. So now if I come back over here, my balance is back to 100 million ETH. I'm going to make a transfer. As you can see, it's immediately updated. We just lost 1 ETH instead of the fees. And OK, I think I probably made a mistake in updating the storage slot. But yeah, the idea is I could just update the storage slot for the name variable, and I should have been seeing USDC over there. But yeah, I think I probably made a mistake there. So that's pretty much it, guys. It's not very difficult to deploy a Madara app chain. If you want to talk more about this, I'll be here. Would love to answer questions. I think we have around 40 seconds right now. So if anyone has any questions, feel free to answer them. Would like to answer them. Okay, awesome. Thank you.